we did yesterday of all the steps that I talked you through on how to actually graph one of these quadratics by hand. When it's in this particular form, right? This is the standard form, remember, ax minus h quantity squared plus k. We like this form because the vertex is just staring at us, h comma k, and we get a variety of other things. That's what we did yesterday. So this one happens to be in this form, which is good for us. So what's the very first thing that we had to do? Step number one, looking at this. What do you guys got? What do you remember from yesterday? Yes, what is it?
Didn't we have to identify what we know?
Yeah. So the first thing that we did was figure out if it opens up or down. Well, yeah. Which way did this one open? Down. Yeah, this opens down. How do you know this? Yeah, because the a is less than 0 in this case, right? In this case, the a is a value of -1. -1. And there it is right there, -1. So we know it goes down. Good. Step number 2, what do we do? Identify the what? The vertex. Very good. And the axis of symmetry. Good. The vertex for us is -3, comma 2. That's so nice. It's so nice that this step has been done for us because that's the beauty of this form. That's why we like it so much, all right? We also know the axis of symmetry. In this case, the axis of symmetry is going to be which line? Yeah, it's going to be the h. Very good, yeah? X equals -3. Very good. So the axis of symmetry is x equals -3. All right, the third thing that we had to do, after now that we know it opens down, we have the vertex, the axis of symmetry, we need to get the x-intercepts, right? All right, how do we get the x-intercepts? No, that's the y-intercept. We set f of x equal to 0 and solve. Okay. So what does that mean? Well, f of x is right here. It's the negative of x plus 3 squared plus 2. I set that equal to 0. 0 equals the negative x plus 3 squared plus 2. And I solve. Okay, so how do I solve this? What am I going to do? Subtract 2. Very good. -1 times an x plus 3 squared. I like to write that -1 on the outside there to remind myself that negative means is -1. Okay, what's my next move going to be? There you go. So it looks like 2 is equal to x plus 3 squared. Next move. Very good. So plus or minus the square root of 2 is equal to x plus 3. Subtract 3, so therefore x must be -3 plus or minus the square root of 2. Right now, I need you guys in your calculators to give me the decimal approximation to 1 decimal of -3 plus the square root of 2 and minus the square root of 2. So there's 2 of these here. Give me the -1.6. Okay, we are all saying this is -1.6. And then the negative one? -4.4. Okay, so these are my decimal equivalents. This is the positive and the negative one of -3 plus or minus the square root of 2. No problem there. Good. The other thing that we need to get is the y-intercept. To get the y-intercept, we evaluate. What does the word evaluate mean again, everybody? Yeah, evaluate f of 0. Plug in a 0. So f of, oh, there's in blue here. So f of 0 is going to be, what was the original function again? Here we go. -0 plus 3 squared plus 2. So that looks like the negative of 3 squared plus 2. That looks like -9 plus 2. That looks like 7. So the y-intercept is the point 0, comma, -7. Thank you. -7. Quadrants 2 and 3. So giving a little bit of thought to where your vertex is, what quadrant this is in, is going to help you draw your coordinate plane. So we want to highlight quadrant number 2 and 3 because this parabola opens downward and the vertex is at -3, 2. So that's what I'm going to do. I'm going to draw my coordinate plane, and I'm going to highlight. You never seen that before? No. Oh, there you go. I'm going to highlight quadrant number 2 and 3. Okay. This is going to set me up well to get all the information. Yeah. Yeah, we'll walk you through it. All right, so now that we've got our quadrant highlighted, we're going to put our vertex on there. The vertex is at -3, 2. So negative 1, 2, 3, 1, 2. So put a dot. And please label this vertex negative 3, comma 2. Once we have our vertex, we can plug in our axis of symmetry. And the axis of symmetry is traditionally a red or a dotted line. It doesn't need to be red. So here's my x equals negative 3. Whoops. All right, so I have my vertex. I have my axis of symmetry. Where are my x-intercepts? Well, this is why we needed decimals. One of them is at negative 1.6. So here's negative 1, and then a little bit more would be right about there. That's an x-intercept. The other one is negative 4.4. So negative 1, negative 2, negative 3, negative 4, and then a little bit more. So these are my two x-intercepts. X-intercept, x-intercept. I also know my y-intercept because we figured that out back in here, and it's at the point 0, negative 7. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7. Boom. Putting this point on the graph. Now here's the great part about the axis of symmetry. If I am exactly 3 units away from the axis of symmetry to the right, then what point is guaranteed to be on the graph in the opposite direction? 1, 2, 3. This point, check it out, is guaranteed to be there. That's the beauty of the axis of symmetry. Now you have everything that you need to smoothly and accurately draw a really good sketch here. Right. Okay, so what's the formula again? The function? It was negative, and then x plus 3 quantity squared, and then plus 2. Now, if we just go a regular zoom 6, right? We're going to get this picture over here. And I want to change my window so that it actually looks more like what I graphed over here on the right-hand side. So I'm going to go to my window. My x minimum, it looks like it's negative 1, 2, 3, 4, 5, 6. Looks like negative 8, okay. My maximum is 2. Yep, I agree. My scale is by ones. I go every 1 unit. My lowest y value is 9. Yeah. And then my max y value looks like, what, 3? About 3? Look up there, 3. And my scale is 1s. So when I hit graph now, I should see a picture on the calculator that looks exactly like what I calculated on my paper. Let's go. Hey. All right. For box number 2, the second part of the lesson, we're going to graph this quadratic. What's the fundamental difference between this one and the one that we just did? It's not in standard form, okay? This is in the form ax squared plus bx plus c. Nothing wrong with that. Nothing wrong at all with that, right? However, if we wanted to get it into this form, a times x minus h squared plus k, we have to do something. We have to do something in order to do that. And the way that we'd get that is we would complete the square. So this is going to play a part in when we try to figure out the vertex, all right? We can still get a lot of information about this quadratic without doing anything right off the bat. So like, for example, number 1, does it open up or down? And how do you know this? It opens up because a is greater than 0. In this case, a is a value of 2. And there it is sitting right out in front. Good. Number 2, vertex. Uh-oh. Where is the vertex? Well, I don't know where it is because it's not in this form, and I can't just read it and look at it, right? Okay, so we have some options here, and you may recall this from the video yesterday. We have 2 ways to do this. We can complete the square, which you did as a warm-up today in the quick start, or we can take negative b over 2a and f of negative b over 2a, and I'm going to show you both of them for ways of getting the vertex. All right, I'm going to show you both of them, and we'll talk about their differences. So the first one, I start with this. F of x is 2x squared minus x plus 1. I just rewrote the problem again. All right, if I'm going to complete the square, then I'm going to say, all right, f of x is going to be a factor out of 2. Now that gives me x squared minus how much if I factor out a 2 from that? Very good, 1/2 x. And then I'm going to have plus 1. So far, so good, everybody? Does everyone see where the 1/2 comes from? Yes? Everyone on board with the 1/2?
Yes.
Good, okay. You're just trying to get on the video, I know. All right, so f of x equals, so I'm going to have 2 times x squared minus 1/2 x plus something, don't know what it is yet, plus 1, and then minus that same thing. Does everyone notice that I am adding and subtracting the same amount to keep my equation balanced? You guys cool with that part? Yeah, okay, good. Great. So let's figure it out here. All right. What number goes right here? Well, we have to look at the b value. The b value is 1/2. What's half of a half? 1/4. What's a fourth squared? No. 1/16 goes here. Okay? Now you would think 1/16 should go here too, but it doesn't, because we have to multiply it by a factor of 2. So what's 2 times a 16th? 1/8. Right? 2 times the 16th is 2/16, which is an eighth, right? All right, we are nearly done. Check it out. F of x equals 2 times the quantity x minus 1/4 squared plus, now check this out. This is like 8/8 minus 1/8. How much is that? 7/8. There we go. Now, where did this 1/4 come from? From completing the square, right? Yeah, that's the perfect square trinomial breakdown. So, ladies and gentlemen, we are in good shape because now I know exactly where the vertex is. It's at the point 1/4, 7/8. Keep in mind that we are taking the opposite sign here to get that, to generate that 1/4. I would think it's probably the one you did last year, right? All right. The other way to do this is to take negative b over 2a and f of negative b over 2a. So watch what happens here. So a is a value of 2. B is a value of -1, and C is a value of +1. I'm just looking over here because that's my function, right? Good. If I take negative b over 2a, look what I get. I get -2, all divided by 2 times, oh, sorry, -1, thank you. All divided by 2 times 2. Thank you. Yeah, sorry, I want a negative of -1. There we go. Which gives me a positive 1/4. Hey, check that out. That was fast. That's exactly what it says down there. Those match up in green. That's pretty cool. I'm sure you do. But how do I get the 7/8 out of this now? What do I do? Yeah, I want f of 1/4, which is 2 times 1/4 squared minus 1/4 and then plus 1. Well, that's going to give me 2 times, this is like 1 squared is 1, 4 squared is 16, so that's 1/16. Minus a fourth plus 1. 2/16 is 1/8, right? This is 2/8, and this is 8/8. Why am I putting 8s everywhere? I don't get it. Yeah, so let's see here. 8 minus 2 is 6, and 1 is 7. Hey, 7/8. Check that out. That's exactly what it says here and here. Now, do we have the axis of symmetry? Yes. All right, good. So the axis of symmetry now, we all agree, is the line x equals 1/4, yeah? Okay, good. So we have a lot of information so far. Next, I know, load disk space. Next, we need the intercepts, right? This is step 4, right? Step 3? 3, thanks. Third step, we need the x-intercepts. All right. How do I get the x-intercepts again? Yeah, set f of x equal to 0 and solve. Okay, now, this is a very important concept that we're going to talk about right here. I have this is f of x. You guys agree with that? Okay. Do you guys also agree that this is also f of x? These are the same thing, aren't they? Do you guys agree with that? Well, if I choose the one on the top, that's a quadratic. I have to solve it by completing the square, which I kind of already started. Quadratic formula to get my x-intercepts. So it would be easier if I just used this one. If I just use 0 equals 2 times x minus 1/4 squared plus 7/8. That's easier. I do not need to use the quadratic formula for that. Do you guys agree? Yeah. So that's another benefit to getting the vertex by completing the square, is you get to use it in step number 3 without using the quadratic formula. So anyways, check it out. I have negative 7/8 equals 2 times x minus 1/4 squared. Remember, I'm getting the x-intercepts here. All right, so I'm going to do divide by 2, divide by 2. So what is this going to be? Negative 7, what, 16ths? Is that right? Equals x minus 1/4 squared. What's my next step going to be, guys? Take a square root, take a square root. So simplify the left side for me. What do you get? Rad 7I over 4. What type of number is this? This is an imaginary number. Now, you guys, I want you to point something out. We didn't need to actually do this. Okay? And check, here's why. You want to know why? Because you guys told me this parabola opens up and the vertex is above the x-axis. Is it ever going to hit the x-intercepts? No, it's not. So it's conceptual, right? Look at all the light bulbs. Oh, minds are blown everywhere. It's amazing. So if you know your parabola opens up and your vertex you have found is above the x-axis, well then how could there ever be an x-intercept? And isn't it cool that the mathematics proves it to us by saying you'll never find a real number in which this parabola will cross because it's going in the other direction. So my question to you is there another situation in where this could also happen? Very good. If it's opening downward and your vertex is below the x-axis, very good. You would still get imaginary solutions. Very good. Awesome. No, that's why I brought it to your attention. Like, look at it. Be smart about it. Okay. Okay, y-intercepts. Check it out. How do I get the y-intercept again? Evaluate f of 0, right? Well, check this out, dude. F of 0 is just going to be the c. So there's a benefit to having it in that way, right? If I plug in a 0, that's like a 2 times who cares minus who cares plus 1. Hey, 1. Awesome. So the c value in the regular form of a quadratic will always be your y-intercept. Ah. Look at all these connections we're making. So that's going to be 0, comma, all right? We're highlighting quadrant 1 and then going into quadrant 2. Now, I'm going to choose something that you maybe not have thought of. I'm going to choose to use a scale of 1/8. 1/8, 2/8. Wait. Why are you upset?
No, that was pretty tricky. Yeah. Use the tick mark. Yeah, as a 1 in a fraction.
Oh, yeah, I know. That was cool, huh? That should have done that, huh? So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Oh my gosh. Don't freak out because after all, this is just the number 1. This is just the number 1/2, and this is still 0, right? They just look better. That's the joy of fractions. This is why fractions are useful. We can actually scale things to whatever we want them to be. Yes? Yep, because we're going up 7 of them, right? The question was, does the y-axis have to also be up scaled by 1/8? And I said, yeah, because we're going to go up 7 of them. So 7, look at me. Sorry. So 1/8. Yeah, that was pretty cool, huh, making that line. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. After all, this is just the number 1. This is still the number 1/2. This is still the number 0. Okay, we're good to go there. Now it makes finding the vertex really, really easy. The vertex is over 1/4. Where's 1/4 again? Oh, 2/8, and then up what? Oh, now I know exactly where the vertex is. It's at 1/4, comma 7/8. And you guys, it's okay to make your scale fractions. You're totally welcome to do that. Take advantage of them. Okay, here's our axis of symmetry. Right here. There are no x-intercepts. We know that. And we know the y-intercept is at 0, 1. Well, 0, 1 is 8/8. And I know that if I'm exactly 2 units to the left, I go 2 units to the right. That's the beauty of the axis of symmetry. And I have everything available to me to draw. All right. Okay. Here's how I like it. I want you to just... All right. Here is... feet from the point which the ball is punted. Here are questions to think about. Good. That's where he's kicking the ball from. He's 1.5 feet above the ground. Right? The question I have for you is, yeah, parabola? The game. Hold on a second. Okay. Okay, that's right. All right, we're going to calculator, and we're going to do some. Parentheses 9 divided by 5 plus the 1.5, which is the on what it is you're looking at.
No, it's actually like.
Huh. Do we care about over here? No. Do we care about stuff like below the X? Not bad. Okay, Tommy. Tommy, can you give us your window? Nice, Tommy. Okay, now check this out. Picture, and since we have a and he has 25, so like 220 feet or so. Wants a left bound from which it's calculating a maximum. So you need no. So check it out. So I want the highest these two triangular regions. Push it one more time, and bam! We get a maximum height of 104.05 feet at a distance of 100.9 feet away from the kicker. Ladies and gentlemen, what is this point called? The vertex. Very good. This is the very, very good. You have now found maximum height using the vertex. Very good job. So this dude over here, and makes it. Now, Ask, based on the picture, if the football, how high does the football player need to jump if he is 6 feet in order to block the kick? Check this out, you guys. Go second. Watch this. Second, calculate. Go to value. If you go to value and you punch in 6, look what you get back. He's jumped 12 feet in the air to block that kick. Is he going to do that? He's not going to do that, right? He's not going to make it. So he needs to be a little closer, doesn't he, that kick? He needs to be at, like, what value do you think? He's got to be 3? Yeah, 3 feet, he could block the kick. Maybe 4. All right, awesome.